Imagine looking up one morning and seeing a blinding light streak across the sky. Within seconds, the earth shakes beneath your feet, the air starts to heat up, and the sky glows like fire. That's what it might feel like if a 5-mile wide asteroid slammed into California. And in this case, there wouldn't be much warning. Even if we saw it coming a few days before, there would be almost nothing we could do to stop it. A 5-mile wide asteroid is about the size of Mount Everest, and when something that massive hits Earth at around 40,000 miles per hour, it's not just a local disaster, it's the kind of event that could change the planet. If it struck on land anywhere in California, the first thing to go would be the ground itself. The moment of impact would release energy equal to billions of tons of TNT. That's more powerful than every nuclear bomb ever made combined. The explosion would create a fireball miles wide, instantly vaporizing everything near the point of impact. Cities, highways, forests, gone in an instant. The temperature would rise so fast that people in buildings within hundreds of miles would be incinerated before they even heard the sound of the explosion. The impact would throw huge chunks of earth and rock miles into the sky, sending a massive shockwave rippling out in all directions. Buildings would collapse, power lines would be ripped down, water pipes would burst. Everything in the surrounding area would be leveled. This wave would move so fast and hit so hard it would be like a hurricane, an earthquake, and a volcanic eruption all rolled into one, but worse. If it hit near Los Angeles, the city wouldn't just be destroyed, it would be completely erased. Right after the impact, a massive crater would form, likely over 50 miles wide and several miles deep. The surrounding landscape would be reshaped forever, and the debris, blasted into the sky, would block out the sun across much of the western United States. Fires would break out for hundreds of miles, burning uncontrollably as emergency systems collapse and response crews are completely overwhelmed or wiped out themselves. But the destruction wouldn't stop there. The energy from the impact would trigger massive earthquakes across the western part of the country. The San Andreas Fault would likely rupture in multiple places, and new fault lines might even open. The shaking would be felt across state lines, toppling buildings in places as far away as Arizona and Nevada. Tsunamis would also be triggered, crashing into nearby coastlines. If the asteroid hit even partially in the ocean near California, the waves would be hundreds of feet tall, slamming into the shore within minutes. This is just the beginning of what would follow. The first few minutes alone would be unlike anything humanity has ever seen. And for the people in California and the nearby regions, survival would depend entirely on distance and luck. Now, the wave of destruction begins to spread across the map. Let's look at what happens next. Within the first hour after impact, the destruction would keep spreading far beyond California. Massive shock waves would roll across the western United States, toppling buildings as far as Salt Lake City, shaking the ground in Denver, and breaking windows in cities over 1,000 miles away. Roads and highways would be torn apart, bridges would collapse, and power grids would fail. Millions of people would be cut off from help, with cell towers down and communication systems overloaded or completely destroyed. The western skies would be filled with thick black smoke, ash and dust rising from thousands of fires. Some started by the heat of the blast, others by broken gas lines and collapsing electrical systems. Inland cities like Fresno, Bakersfield, and Sacramento would be reduced to rubble from the force of the shockwave alone. Buildings that weren't destroyed instantly would soon be brought down by aftershocks and spreading fires. Hospitals, police stations, and emergency services would either be gone or overwhelmed. Survivors would be scrambling to find clean air, shelter, and water. With debris covering the roads and the entire region in chaos, evacuation would be nearly impossible. Planes wouldn't be able to fly through the ash-filled skies, and helicopters could only reach a limited few before running out of fuel or being grounded by dangerous winds. As the blast zone widens, coastal cities like San Diego, San Francisco, and even parts of Seattle would be hit by massive tsunamis if the asteroid struck near the Pacific Ocean. These waves could reach heights of several hundred feet, flooding entire cities and washing away ports, airports, and residential areas. The salt water would flood deep inland, leaving behind toxic sludge and wreckage. Ships out at sea would either be capsized or lifted and hurled onto land by the force of the water. Entire neighborhoods would be swept away like driftwood. Meanwhile, the skies would darken across the entire continent. The asteroid would throw up millions of tons of dust and ash into the atmosphere, carried by the upper-level winds across the country. Places as far as Texas and even the East Coast would soon see ash falling from the sky like dirty snow. The The sun would grow dim and temperatures would begin to drop, especially at night. People would be forced indoors, not just because of the danger, but because the air would be filled with ash particles that could clog lungs and poison water sources. By the end of the first day, tens of millions of people across the western half of the country would either be injured, displaced, or missing. Emergency broadcasts would play on repeat if they were still functioning, warning people to stay inside, wear masks, and avoid contaminated water. The US government and military would begin mobilizing, but the scale of the disaster would be beyond anything ever prepared for. Entire states would essentially be cut off, operating without fuel, electricity, or any connection to the outside world. And the worst part, this was still only the beginning. In the next part, we'll look at what happens over the next week and month, how far the damage spreads, which cities survive, and what the world starts to look like as the ash settles. Over the next few days, the damage would grow even worse as the full effects of the asteroid hit start to unfold. California, once home to nearly 40 million people, would now be unrecognizable. Entire city maps would be useless. Craters, collapsed highways, and flooded coastlines would erase any familiar landmarks. Survivors in Central and Southern California would have no electricity, no clean water, and very little access to food. The government would try to deliver emergency aid, but most airports would be destroyed, and the skies would be too dangerous for regular air traffic. Military cargo planes and helicopters would be forced to land in makeshift zones far outside the impact area. Beyond California, neighboring states like Nevada, Arizona, and Oregon would begin to feel secondary effects. Hospitals in cities like Phoenix, Las Vegas, and Portland would be overwhelmed as evacuees flood in, many suffering from burns, broken bones, and lung damage from breathing ash. Grocery store shelves would empty in hours, gas stations would run dry, and traffic out of the west would clog every major road. Entire communities would set up camps in parking lots, schools, or open fields just to have somewhere to sleep. Cities once thought to be safe would struggle under the weight of refugees and the collapse of basic systems. Meanwhile, the skies would continue to grow darker. The dust and ash pushed into the upper atmosphere by the asteroid would start to block sunlight across much of the western hemisphere. By the end of the first week, daytime would look like evening in many places. Crops would begin to die from lack of sunlight, and temperatures would drop noticeably. In California's Central Valley, where much of America's produce is grown, farms would be buried under layers of soot. The food supply chain, already fragile, would begin to break down. The effects would stretch across the country, with prices rising and panic growing. Wildlife across North America would be thrown into chaos. Forests near the Rockies and along the west coast would burn uncontrollably, releasing more smoke into the atmosphere. Rivers and lakes would become clogged with debris and polluted from chemical runoff and dead animals. Birds would fall from the sky, confused by the lack of light, while fish die-offs would begin in both saltwater and freshwater systems. The sound of sirens, distant explosions, and silence where bustling cities once stood would be all that remained in many parts of the western United States. By the end of the first month, millions of people would still be unaccounted for, and entire regions would be labeled as unreachable. National and international aid would begin pouring in, but even the rest of the world would start to feel the ripple effects. Trade routes through California's major ports would be destroyed, stock markets would spiral, and the rest of the planet would watch and wait, wondering how bad the long-term consequences could really get. In the final part, we'll take a look at what life could look like 1 year after the impact, how the world adapts, what's left of the West Coast, and the lasting scars this event would leave on the planet. 1 year after the 5-mile-wide asteroid hit California, the world would be in a completely different place. The physical damage in California would still be beyond repair. Cities like Los Angeles, San Diego, and Sacramento would no longer exist in any recognizable form. What was once dense urban sprawl would now be a mixture of dry craters, twisted metal, collapsed concrete, and growing vegetation trying to reclaim the ruins. The crater itself, several miles wide and hundreds of feet deep, would be filled with stagnant water surrounded by the skeletal remains of highways and buildings. It would become a dead zone, not just from the impact, but from radiation and lingering atmospheric poisons kicked up during the explosion. For those who had survived, life would be about survival, not rebuilding. Makeshift towns would rise in the outskirts of the country, formed from shipping containers, scrap metal, and salvaged supplies. Most survivors would live without electricity, plumbing, or regular medical care. Diseases would spread faster in overcrowded shelters, and clean water would still be a daily struggle. Many would have moved to the east, trying to escape the choking air and find stability, but the entire country would be facing its own set of problems by then. The rest of the Russia United States would now be dealing with a completely shifted economy. With California's agricultural centers gone, there would be a long-term food shortage. Farms in the Midwest and Southeast would try to keep up, but the loss of the Central Valley alone would have driven produce prices through the roof. Gas and oil would become even harder to transport, with so much of the West Coast shipping infrastructure destroyed. Unemployment would skyrocket, whole industries tied to the tech world, entertainment and trade would disappear overnight. The economic weight of rebuilding just a fraction of what was lost would be unlike anything the country had ever faced. The atmosphere itself would still be unstable. With so much ash and debris pushed into the sky, weather patterns would shift dramatically, global temperatures would drop. What scientists call an impact winter would settle in. Crops around the world would suffer, not just in the US, but across Europe, Asia, and parts of Africa. The sky would remain tinted in shades of gray, with red sunsets and dim mornings becoming the new normal. Climates would change rapidly, causing storms in places that rarely experienced them and drying out areas that used to be lush. But even with all this destruction, the world would try to move forward. People would form new governments in damaged regions. Aid from around the globe would help keep some areas stable. Scientists would spend years studying the crater, the asteroid fragments, and the effects on Earth's climate. And slowly the global conversation would shift from shock to survival, then to prevention. It would become clear that space isn't just vast and empty, it's filled with potential threats. And after witnessing what a single rock 5 miles wide could do, no one would ever look at the sky the same way again. It starts with a simple glance up at the night sky, that quiet glowing face we've always known as the moon, steady, peaceful, and constant. It's been up there for billions of years, circling our planet like a silent guardian. But what if one day that calm was shattered by something completely unexpected? Not an asteroid heading for Earth, but one barreling straight toward the moon. Imagine a colossal asteroid, a frozen rocky mountain drifting through the void, slamming into the moon at thousands of kilometers per hour. No warning, no defense, just a violent, unstoppable crash. It's the kind of impact that could leave the moon scarred forever and send shockwaves of chaos down to Earth. We always think about asteroids as threats to our planet, but what happens when they strike something just one step away? This is the story of what could unfold if the moon took the hit for us, and why that might not be the lucky break we think it is. Now picture the moment it happens. No sound in space, but from Earth, you'd see it. A blinding flash erupting on the moon's surface, bright enough to be visible even in the daylight. An asteroid, perhaps several kilometers across, crashes into the lunar crust with unimaginable force. In an instant, the quiet moon becomes the site of a cosmic-level collision. The blast unleashes more energy than every nuclear bomb on Earth combined, and then some. The moon's surface, already cratered and ancient, would be violently transformed. A new massive impact basin, possibly hundreds of kilometers wide, would be carved out in seconds. Superheated rock and vaporized dust, what scientists call ejecta, would shoot outward in every direction. Some of this material would escape the moon's weak gravity entirely, flung into space at speeds of several kilometers per second. The landscape would ripple with seismic shock waves, likely fracturing deep beneath the surface and permanently altering the moon's internal structure. And remember, the moon doesn't have an atmosphere to slow anything down. Every bit of debris from this impact is raw, fast, and deadly. Towering plumes of dust would rise and fall in total silence, leaving behind a brutal new scar for Earth to see, a reminder of just how suddenly everything can change in the cosmos. But the real problem, what happens next, when all that material starts moving through space? Because not all of it is going to stay up there. Some of it is coming straight back to us. In the hours and days that follow the impact, Earth would begin to experience the real consequences. At first, the signs might seem beautiful, an extraordinary meteor shower lighting up the sky. But this time, those glowing streaks of light wouldn't be harmless. They would be the first wave of lunar debris racing through space and slamming into our atmosphere. The initial wave would mostly be smaller fragments, bits of vaporized lunar rock and dust, no bigger than pebbles. These would create a dazzling but dangerous light show, as countless particles burn up high in the upper atmosphere. Entire skies could glow for hours at a time, even during daylight. But this is only the beginning. Mixed in with the dust storm are much larger, heavier chunks, everything from rock fragments the size of baseballs to debris as large as small houses, and they would not all burn up. Earth's atmosphere can usually break apart smaller meteoroids, but bigger pieces, those could survive the fall. Hundreds, possibly thousands of meteorites would crash across continents and oceans. Most would not be big enough to cause mass extinction, but enough of them could cause serious destruction. Imagine random impacts flattening homes, sparking fires, or pummeling highways and farmlands. A single lunar boulder crashing into the ocean could trigger dangerous waves, or even regional tsunamis. Even beyond Earth's surface, our orbiting satellites would be at risk. The moon's debris cloud would be filled with tiny but fast-moving particles, fast enough to rip through metal. Communication networks, GPS systems, weather tracking, and surveillance infrastructure could all be knocked out. And since this rain of particles would continue for days or even weeks, the damage to satellites could be widespread and ongoing. The Earth wouldn't be hit all at once. This fallout would arrive in unpredictable bursts, creating fear and uncertainty across the globe. And the worst part? No one would know exactly where the biggest pieces might fall next. The impact that began in total silence on the moon would become a loud, chaotic, and potentially deadly crisis back on Earth. With Earth enduring the fallout, the long-term questions would begin to take shape. The moon itself, while still hanging in the sky, would no longer be the familiar, stable companion we once knew. Even though the moon is massive, far heavier than any asteroid that might hit it, an impact of this scale could still alter its behavior in subtle but serious ways. The odds of the moon being knocked out of orbit completely are extremely slim. Its mass is so great that even a giant asteroid, something the size of the dwarf planet Ceres, would barely budge its path. But not all changes would be dramatic. A high-energy impact could slightly shift the moon's axial rotation, or nudge its orbit just enough to disrupt the delicate gravitational balance it shares with Earth. These small adjustments might not be visible at first, but their long-term effects could be significant. Our tides are governed almost entirely by the moon's gravitational pull. If the moon were to lose a large portion of its mass, or change its position, even slightly, Earth's ocean tides could shift in unpredictable ways. Lower tidal ranges would hurt coastal ecosystems that depend on the rise and fall of water. Shorelines, wetlands, and estuaries, places where life has evolved over millions of years, would struggle to adapt. Sea creatures that rely on the moon's pull to breed, feed, or migrate could begin to vanish. And then there's Earth's tilt. The moon acts as a kind of cosmic stabilizer, helping to keep our axial tilt in check. Without it, or if the moon were to become much smaller or lighter, Earth could start to wobble. This wobble, over tens of thousands of years, would swing our planet's tilt from nearly 0 degrees to as much as 45 degrees or more. That might not sound extreme, but such a shift would totally change global climates. Regions that once had moderate seasons could face brutal winters or endless summers. Some areas might turn into deserts, while others would freeze year-round. Agriculture, one of the foundations of human civilization, could become almost impossible in certain zones. And over centuries, entire populations would be forced to migrate as Earth's climate reshaped itself in unexpected and chaotic ways. So while the immediate threat of the impact is terrifying, it's the slow unraveling of our planet's balance that could prove even more dangerous. The moon doesn't just light up our nights, it keeps Earth steady. Without that, the world we know could slowly start to drift into one we no longer recognize. As the years stretch beyond the initial chaos, the true scale of this lunar catastrophe would slowly start to reveal itself. While the bulk of the lunar debris might fall to Earth over days or weeks, the smaller particles, the fine moon dust blasted into space, could remain suspended in Earth's upper atmosphere for years. This high-altitude haze would scatter sunlight, possibly dimming the skies and dropping global temperatures in a phenomenon similar to what happens after major volcanic eruptions. This impact winter might not be as severe as one caused by a direct hit on Earth, but even a mild, persistent cooling could disrupt weather patterns and shorten growing seasons. Crops in some regions could fail, other areas might face unpredictable droughts or flooding. A few degrees of global temperature change is all it takes to shift ecosystems, forcing entire food webs to adapt or collapse. Farmers, already reeling from lunar debris, damage, and satellite disruptions, would now have to contend with a climate gone strange. Meanwhile, Earth's night sky would look unfamiliar, even haunting. A giant new crater would scar at the moon's surface, visible even to amateur astronomers with backyard telescopes. If enough ejecta escaped the moon's gravity and got caught in Earth orbit, we could see something no one has ever witnessed, a faint ring system around our planet. Like a dusty halo, this ring would shimmer faintly in the darkness, changing how our nights looked and felt. It might even increase nighttime brightness temporarily, especially in areas already lit by city glow. But these rings wouldn't last forever. Over time, gravity and atmospheric drag would pull that material back down to Earth, causing sporadic meteor showers that could last for decades, maybe even centuries. For future generations, streaks of moon dust lighting up the sky could become a common sight, a recurring reminder of the day everything changed. And what if the impact had been even worse? Say if a massive section of the moon had broken off. The consequences wouldn't just be visual or climatic. Many nocturnal animals, tuned to the moon's light for hunting, navigation, and breeding, would lose a key environmental cue. Species could vanish simply because their world went dark. For humans, the psychological effect of a mangled or missing moon could be profound. After all, it has guided our myths, our calendars, even our sense of time and rhythm for tens of thousands of years. So even if Earth survives the worst of the physical damage, the moon's transformation would mark the beginning of a different kind of era, one shaped not just by altered tides or dimmed sunlight, but by the long shadows of a sky we no longer recognize. The moon would no longer be a silent guardian. It would be a monument to what could happen when cosmic forces collide in the wrong place at the wrong time. As the chaos begins to settle, Earth enters an unfamiliar chapter, one where daily life is shaped by an event no one alive has ever experienced. The dust storms clear, the debris showers lessen, and the skies begin to stabilize, but everything beneath them has changed. For billions of people, the priorities would shift quickly from awe to survival. With damaged infrastructure, collapsed food supply chains, and unreliable communication systems, countries would be forced to rebuild under new conditions. Emergency efforts would focus on stabilizing cities hit by falling debris, restoring power grids damaged by satellite outages, and relocating coastal communities grappling with altered tides. Agricultural zones may have to shift entirely, especially if the impact winter had any lasting effects on temperature and rainfall. In some regions, crop yields might plummet for several growing seasons, forcing mass migration and sparking political unrest. Nations would compete for fertile land, stable climates, and fresh water, all while navigating a disrupted global economy. Scientists and engineers would be racing to understand the moon's altered behavior. Even minor changes in its orbit or spin could have knock-on effects we don't yet fully understand. Predicting tides, tracking long-term climate patterns, and maintaining global navigation systems would become more difficult. For researchers, it would be an unprecedented opportunity to study planetary scale change in real time. For everyone else, it would mean adapting quickly or suffering the consequences. But the psychological aftermath might be even deeper. The familiar night sky, now permanently changed, would become a symbol of vulnerability. For millennia, humans have looked to the moon as a constant. Its phases guided ancient calendars, inspired entire mythologies, and acted as a silent witness to our history. Now that symbol would be cracked, possibly half-lit, maybe even orbiting a few degrees differently, always reminding us of just how close we came to something far worse. Culturally, this could spark a shift in human thinking. People might begin to take cosmic threats more seriously. Asteroid detection programs could receive major boosts. Governments might invest more heavily in space infrastructure, not just for exploration, but for planetary defense. Lunar colonies or off-Earth observatories could go from science fiction to global priorities. And the public? They'd likely become more attuned to the idea that Earth's place in the solar system is fragile, and that survival might require thinking far beyond our atmosphere. So even if life eventually returns to something like normal, it would never be that normal again. This kind of event wouldn't just reshape land or sky. It would change how we think, plan, and prepare. The moon's scar would become a warning. The solar system does not care about our schedules or civilizations. Its violence is ancient, random, and inevitable, and the next target might not be so distant. When the dust finally settles, literally and figuratively, the world would be left forever altered, not just by the damage, but by the realization of how closely we are tied to the moon. The final stage of this disaster would not be a dramatic explosion or a city-leveling impact, but a slow, sobering shift in human understanding. The moon was never just a light in the sky. It was, and still is, our stabilizer, our timekeeper, our shield. The crater now carved into it, or the pieces that may remain if it fractured badly, would become symbols of vulnerability on a cosmic scale. In this new era, Earth's rhythms could feel off. With altered tides, disrupted seasons, and unfamiliar skies, daily life would carry an eerie sense of imbalance. Generations raised with the full moon would now grow up under a dimmer, maybe broken celestial body. Lunar eclipses would no longer look the same. Entire cultures that built mythologies around the moon might have to reimagine those stories. Our calendars, once synchronized with the lunar cycles, could become increasingly detached from what remains of that rhythm. And if the moon had been shattered, beyond repair if it became a field of debris instead of a single body, the consequences would stretch far into the future. Earth's orbit could accumulate dangerous clutter, making space exploration and satellite deployment more hazardous. For astronauts and space agencies, just getting into orbit could become riskier than ever. Nighttime would grow darker, colder, and emptier, especially in regions that once relied on moonlight for navigation, wildlife movement, and even agriculture. In a quiet but profound way, the world would become lonelier. But perhaps the greatest shift would be in how we view our place in the universe. A giant asteroid hitting the moon instead of Earth might at first seem like a lucky break, but in truth, it would show just how thin the line between safety and catastrophe really is. Earth didn't dodge a bullet, it just watched that bullet hit something it loves. This kind of event would change education, culture, politics, and science all at once. More people would push for asteroid defense systems. Funding for space weather forecasting and cosmic threat detection would explode. The idea of lunar colonies could transform from a scientific dream into a survival strategy, and many would start asking the bigger questions about existence, randomness, and how to plan for threats that come from far beyond our atmosphere. In the end, a giant asteroid hitting the moon would not be a problem we could simply clean up and move on from. It would be a defining moment in Earth's history, a cosmic lesson in fragility, a planetary reminder that, in the vast, unpredictable arena of space, we are not spectators, we are participants. And as long as we look up at the sky and see that altered moon, we'll be reminded that the universe is still writing its story. The only question is whether we're ready to read the next chapter. The asteroid slams into the Central Pacific with an energy release equivalent to roughly 60 million megatons of TNT. That is more than 1 million times greater than the largest nuclear weapon ever detonated. The Pacific Ocean, despite being miles deep, barely slows it down. The water instantly vaporizes into a colossal column of superheated steam, stretching dozens of miles into the atmosphere. In less than a second, both the asteroid and millions of tons of ocean are gone, transformed into energy, heat, and chaos. A crater does not form like it would on land. Instead, a temporary cavity miles deep opens in the sea, exposing the ocean floor and punching directly into the Earth's crust. That rupture triggers an earthquake so powerful it exceeds magnitude 12, an intensity no human structure is designed to survive. Surrounding tectonic plates tremble, sending pulses of seismic energy across the globe. As the ocean collapses back into the cavity, an enormous wall of water is ejected outward. The initial wave is more than 1 mile high, an unstable tower of sea surging away in every direction, and it's not just one wave, it is the birth of a tsunami complex so powerful it dwarfs anything recorded in human history. Simultaneously, shock waves explode outward through the air. These atmospheric pressure waves travel faster than the speed of sound, flattening everything in their path. Ships are shattered like toys, birds are instantly killed mid-flight, the winds they carry are stronger than any tornado ever recorded, and they hit hundreds of miles away within minutes. From above, a monstrous plume rises, superheated steam, rock vapor, and asteroid debris reaching the stratosphere. It does not simply drift, it spreads rapidly, carried by high-altitude winds, setting the stage for what is coming next, a planet-wide crisis. The impact is over in seconds, but the consequences are only beginning. With the asteroid gone and the Pacific still heaving from the blow, the devastation starts to spread outward in terrifying waves, both literal and atmospheric. The mega tsunami, born from the impact, a traveling mountain of water, is now surging across the globe. Though the wave lowers as it moves away from the point of impact, it still towers over coastlines thousands of miles away. Within just a few hours, it reaches the shores of North and South America, Southeast Asia, Australia, and island nations caught in the crossfire. Some waves still rise hundreds of feet high, swallowing harbors, cities, and entire regions in minutes. The ocean becomes a weapon, it tears through ports, sends freighters crashing into inland buildings, and turns cars, trees, and homes into projectiles. Coastal populations have little to no warning. Communications are down. Power grids have already begun to fail under the strain of the seismic shock, and satellites knocked off course during the impact are barely functioning. Aid is impossible. Roads are gone, airports are underwater, entire regions are cut off. But what follows from above might be even worse. The massive plume of material launched into the upper atmosphere during the impact has begun to fall back, but it has not come down gently. As billions of particles re-enter Earth's atmosphere, they ignite. What begins as a distant flicker becomes an all-sky rain of fire. Every continent sees it, tiny blazing specks, streaking downward in the thousands. The heat from these returning fragments doesn't just light up the night, it raises atmospheric temperatures so suddenly and violently that dry landscapes, grasslands, and even forests burst into flames before anything touches them. By the end of the first day, global fires rage across multiple continents. From the Amazon basin to Siberian forests, from Australian bushland to the grass plains of North America, the land itself begins to burn. Smoke columns reach into the stratosphere, mixing with volcanic ash from eruptions triggered earlier by the planetary shock. The air is turning black. Volcanoes, long dormant or merely rumbling, have been jolted awake. The energy from the asteroid impact destabilized pressure points in Earth's crust, setting off a chain reaction. Mounts like Indonesia's Tambora, Alaska's Redoubt, and the Pacific's own Ring of Fire begin erupting almost simultaneously. These aren't small eruptions, they are colossal, spewing sulfur dioxide, ash, and rock into skies already choked with soot. Each eruption further dims the sun and cools the planet, and in the oceans, shockwaves from the asteroid continue to echo. Underwater landslides and tectonic disturbances create secondary tsunamis. Currents shift. Oceanic conveyor belts, which help regulate global climate, begin to falter. Ecosystems, both above and below water, are collapsing, fast. Coral reefs bleach instantly under the heat and sediment. Fisheries that once fed millions are obliterated. Within less than 24 hours, the world is barely recognizable. Fires rage, skies darken, and coasts have vanished. But this is only the beginning of a deeper crisis, one that will not just reshape cities and countries, but the entire global climate for years to come. By the time the fires die down and the last tsunamis fade, Earth is already entering a new phase, one far quieter, but even more deadly. Without much sunlight getting through the thick cloud of soot, ash, and aerosols now circling the planet, global temperatures start to plummet. What was once a world of heat and chaos turns cold and dim. This is the beginning of what scientists call an impact winter. Within just a few weeks, crops around the world begin to fail. Farming regions that once produced enough food to feed millions are now covered in frost or drowning in darkness. In tropical zones where temperatures used to hover around 80 degrees Fahrenheit, the mercury struggles to reach 40. In temperate regions, snow falls in what should be summer, and in the northern and southern extremes, the cold is bone deep and endless. Rain no longer falls like it used to. Instead, acidic snow and freezing rains sweep across continents, carrying with them toxins pulled from the atmosphere. The chemicals released by the impact, like sulfur dioxide, carbon monoxide, and nitrates, fall back down to the surface, poisoning freshwater sources and damaging what little vegetation survives. Rivers turn brown, lakes develop oily films. Even groundwater becomes unsafe in many regions. With no functioning agriculture and wild ecosystems collapsing, mass starvation takes hold. Livestock perish in the cold, crops rot or never sprout. Supermarket shelves, if they still exist, are permanently empty. Food becomes a form of currency. Some countries with stored grain reserves last a little longer, but within a few months, most of the global food supply is gone. Cities become silent, not because of tsunamis or fires anymore, but because of hunger. The oceans don't fare any better. Without sunlight, phytoplankton, the base of the marine food chain, virtually disappears. Coral reefs are already dead from the initial shock, but now fish populations crash completely, ocean temperatures fall, entire ecosystems vanish beneath the waves. Survivors are scattered in bunkers, in caves, in underground shelters. Small pockets of humanity huddle together, trying to wait out the cold. Nations have fractured, governments have collapsed or gone dark. Most forms of communication are lost. Power grids are useless, fuel is scarce, the internet as we knew it is long gone. People begin relying on local knowledge, community survival tactics, and sometimes brutal decision-making. And still, the skies remain dim. The once familiar blue has been replaced by a permanent gray shroud. Stars can rarely be seen. The moon glows faintly through the haze. And the sun? It's more of a pale disk now, barely warming the surface, offering little light and no comfort. The global climate has completely shifted, wind patterns change, rainfall stops in some areas and floods others. What used to be fertile land becomes tundra. Regions once too dry for farming now receive too much acidic rain. Coastal areas that somehow survived the waves are now too cold or too contaminated to support life. Months stretch into the first year, and it becomes painfully clear this is not a temporary disaster. This is a planetary reset. The climate system is broken, the biosphere is unraveling, and for the survivors left beneath this altered sky, the question is no longer, how do we fix this, but how do we endure what comes next? Years pass. The thick veil of dust and ash begins to thin, slowly settling into oceans, forests, and ice caps. Bit by bit, sunlight starts piercing through the clouds. Again, but the world it returns to is unrecognizable. Landscapes have shifted, ecosystems have collapsed, and human civilization, once spread across every continent, has been reduced to scattered remnants. As temperatures begin to rise again, this time due to the buildup of greenhouse gases like water vapor and carbon dioxide, the planet enters a new phase. Some regions experience extreme heat, while others face relentless storms or permanent drought. The climate doesn't return to what it was, it transforms into something unstable and unpredictable. In the oceans, life is trying to restart. New microbial life forms begin to appear, feeding on chemicals released during the catastrophe. On land, plants adapted to low light and harsh, cold conditions start to reestablish themselves in small patches, but species diversity is a fraction of what it once was. For the few surviving humans, rebuilding is slow and uncertain. Knowledge has been preserved in some places, but resources are scarce. Cities are buried, power infrastructure is useless, and transportation is nearly impossible. Those who remain rely on old-world tools and ingenuity to grow food, filter water, and survive. Generations later, the event will be remembered not as a singular disaster, but as the boundary between two Earths, before and after. Just as the Chicxulub impact ended the age of dinosaurs, this asteroid has ended the age of global civilization. Earth continues, life returns, but nothing is the same. And above it all, the sky remains a haunting reminder, beautiful, vast, and always carrying the possibility that one day it could happen again.